All right, so I'm gonna talk mainly about how can we model the information, the data that we've collected, in such a way that will make it possible to input within ARCHES and to make use of all the capabilities that the system provides. So again, this is the list of items that we're gonna talk about. And we're gonna begin by taking another look at the relational database that we have looked at before. So it's the same, nothing really changed. And we can still see that it consists of tables, smaller tables that have some relationships to connect them using the primary and foreign keys. Now, one question that this database is not going to be able to answer is what's the difference between the relationship, say here, between the site and the functions, this relationship, and the site and the types of activities that happen on it, this relationship. In terms of relational database, relationships are defined by the tables that connect them and the foreign keys and primary keys that are used to perform this construction. But the relationship itself is not stored as an entity, and it has no properties, it has no description. This might be important for some types of analysis, because you might want to see if an activity is happening on a site, how is it stored within multiple attributes? What that means is you might want to have a relationship descriptor just to describe the relationship itself, just to define what type of relationship exists between the multiple attributes of an entity. This particular problem is tackled by the graph database. So a graph database is a database that allows you to store information about the relationship as well as the entity. Entities here, or tables in the previous databases, are stored as nodes, and the relationships are stored as relationships, with the difference that the relationship can have its own identifiers. So, for example, here, this particular relationship has an identifier of a date. This person started working for this company at that particular date. And this information is stored at the relationship instead of within any of the tables. This is a type of database that in the previous presentation was included with an example of Neo4j, which I have noticed that some people within the audience have used, which is really good. ARCHES does not use Neo4j. ARCHES is using a custom method of developing graph databases to make use of the technologies that are embedded within the system, being Postgres or Elasticsearch. So again, the main difference between the graph database and the relational database is that we can store information directly about the relationships within the database itself, and we can use this information in our queries, so it makes it easier for us to identify any information, any queries that rely not just in the information within the entity, but also in information relates to the data, to the relationship between the entities. Now, this is an example of how a graph database would look like for a particular site. So for this particular site, we have a place, an attribute of place, and this attribute of place has on its own other attributes. For example, place address and description of the location itself, and also spatial coordinates. These attributes here are not directly related to the site, but rather to the place, and then from the place to the site. So we can immediately see another feature of the graph databases, which it looks like a graph, but also the fact that it looks like a graph allows us to have extended attributes for the attributes. What that means is that for this site here, the place is an attribute. It's not its own entity. But then we can describe this attribute with additional attributes. And then these additional attributes can also have their own child nodes, which are additional attributes, and so on and so forth. This can go on forever as a tree. And you can think of it as a cascading tree, because this is exactly what it is. But another feature of the graph database is that we don't really need to store the information directly within the node. We can have nodes here, maybe, or here, just to allow us to add further attributes to describe the initial node here. So we want to organize our database in such a way to say, okay, we have a site, and then we have all these attributes that relate to an attribute of the site. We might not have information about the attribute itself, but we want to describe it still. And the graph databases allows us to do that using this structure of describing the attributes with additional attributes. Okay, so we have been looking, I've been looking at this example, sneak peek. We have been looking at this example for a while now, and we want to see how can we transform this particular example into a graph database or a graph shape of a database. First, we need to look at the central point, or what we would consider to be the entity, the main entity of this particular graph database. And in our case here, most likely this will be the site itself. And then we can start looking at what attributes we can describe for the site. So we can see that there are features associated with the site. We can see that there are organizations and people recorded the site. We can see functions and we can see activities. And for each of these, there are additional attributes that goes with it. So for the features, we have location, we have shapes, counts, and for the activities, we have dates and names. Functions, we have descriptors for them, and for the people or recorders, we have organizations and we have roles. And all of these will be branching out from the main node here. How would this look like? It'll look like this. We have the site in the middle, and then we have a descriptor for the site, which is the name. And we have associated nodes to the site. So we have recorder, which by itself has a role and an organization. And we have feature, which has all these attributes connected to it. We have the activity, which has a type and a date, and we also have the function. And we can see here that this is color-coded to represent the level of connectiveness to the main entity. So the main entity here is red, and you can see everything that is connected directly to it in blue, and then connected to the attributes that are connected to the site are green. Now, one thing you might notice here is that the site itself does not contain much information, but its own attributes are where we store the information. So the site name is not within this node, it's rather here. The site itself is just an instance. And what instance mean in here is that we have to create a container, a first object that will host all the information related to this site. So begin by creating the instance and then add the attributes to it. Now, similar to the relational databases, there are different types of information that we can store. Here, we can take a look at the different data types. So we can immediately see that we have similar types to the relational databases as strings in most of the nodes. We have numbers, which is similar to the numeric. We have booleans, we have dates, and we also have geometry, which Junaid has spoken about. We can also see that there is an additional type that we haven't seen before, which is semantic. Semantic here is more than adding information to the database. It serves as a tool for organizing the graph to make it possible for us to understand exactly the way that this information is connected with each other, and also to make it possible for us to run queries later on. So each of the semantic nodes does not contain information by itself. Rather, it serves as a tool to link the connected information around it together in one data structure. So we have here the function and the name relates to the same site. But the site itself, the node, does not contain any of these information. And the other thing that the semantic nodes help us to have is some sort of an understanding of the connection from the central node all the way to the limits of the tree. So we can see that a feature is connected to the site, and the feature type or the cultural period are connected to the feature, which is connected to the site. So we can use these nodes as a form of a bridge between the end or terminal nodes and the central ones. Now, we have seen almost all of these before, but then within Arch's interface, the design of the graph will look slightly different. It'll look like this. So this is an example of how we can present the graph database within Arches, which has its own name. So in Arches, this will be called a resource model. What that means is that we have modeled the data into a certain structure that can be used within Arches for all these capabilities that Azad have explained. So this serves as a base for all the information within Arches. And as you can see, it looks like a tree because it is a tree. It's just a different form of representation, similar to what you have seen in this slide here. It's just the same thing, organized in a different way. And in this part of the screen, you can see the data entry screen, or part of the data entry screen, for some of the features here, some of the attributes in here. So you can see this, what the Boolean looks like. You can choose either yes or no. This is what the feature count looks like. You can enter a specific number. And this is what the geometry looks like. You can start drawing and tracing objects within Arches. Okay, so we have already talked a bit about different types of data types, but there is one specific data type that Arches tackle in such different way than the normal GIS systems, which is geometry. So normal GIS systems here, I mean things like QGIS, ArcGIS, or any other software you might be familiar with. All of them support similar types of data structure which serve with the geometry in the center. What that means is that in either ArcGIS and QGIS, the main data structures most likely will have one type of geometry. It can either be point, line, or a polygon. There are special cases where when you connect in your QGIS or ArcGIS to a Postgres server, where you will see the fourth type here, the geometry collection. these are not common types. People usually use either points, line, or polygon. But then the downside of using that is that if you have a feature, if you have something you want to describe, which contain all the three or a mixture of the three, then it becomes very, very difficult because you're going to have to use multiple layers to describe it. So you might want to describe a site, and then within the site, there is a central point, there is an outer boundary, and there are tracks. And in order to fully describe each of these, you will have to use a different layer for each of them. So there will be point layer for the center, line layer for the tracks, polygon layer for the outer boundary. Or you can use a geometry collection, which allows you to add all the three together. But then the problem is, how will you describe each one of them? How would I know that the lines are tracks and not outer boundary of the site? This particular problem requires you to have more than one geometry attached with each of the items inside your database, which is not something that is easily designable within the GIS softwares. You can't really do that from the graphical user interface easily. You're going to have to dive under the hood and write your own code for it. Arches allow you to do that. So similar to what we have seen before, that some sites can have multiple recorders, and these multiple recorders can have their own descriptors as well. So there is an organization name, there is a rule for each of the recorders, and we have multiple recorders connected to the site. You can have, instead of this, multiple geometries connected to the site as well. Excuse me for a second. Sorry, in the office. Okay, so as I said, we can have multiple geometries connected to the site, similar to we have in here, multiple recorders connected to the site itself. Not just having multiple geometries connected directly, but we can also have descriptors for these geometries. So here is an example. We have here the pyramids, or rather two of the pyramids, and we have in purple the outer boundaries of the pyramids, and in red there is a central point or king chambers, and then there are tracks similar to maybe a direction towards the center or towards the king chamber. And all of these are stored within arches, but we're gonna see here two different types of representation of how this is represented within the database. So the first one here is that if we use the geometry collection, so we have all the geometries in just one entry, and they're described by the complex. The second one, we have each of the geometry in its own entity with its own description. Arches allow you to do that. And this is extremely powerful if you want to describe multiple geometries, if you want to add any information to these geometries as well within your data structure. Okay, so we talked about the data types. Now we're gonna speak a little bit about relationships, because graph databases, as we said, allow you to encode the relationship information within the database structure directly. We have seen this before, but now we want to take a look at a portion of this diagram. So here we have the site, name, function, and recorder. We have the feature and the location. And as you can see, now we can see some information written on the relationship itself. So the site is recorded by the recorder, and the site is called the name. and it consists of feature, which is located at location. This is really powerful if you want later on to understand the relationships, the types of relationships that exist between any of these entities and the other. Because if you have a site and you have a person, then you might not be able to understand what is the connection between the two unless you rely on the relationship between the two. This allows you as well to abstract this node here to describe just people, and then you can connect the people to the site using different types of relationships. So you can use recorded by, you can use person lived in the site, you can use person living in the site at the moment, built the site, and you can have all different types of people connected to the site here. But one problem with that is that with more information you add to your database, you might have multiple types of relationship that describe pretty much the same thing or similar things. And for this, we need standardization. So this is how the relation, this is the one, sorry. This is, for standardization, we rely on what is called ontologies, which I realize as Ada have talked a little bit about. And ontologies here are a way to build standardized systems for the nodes and for the relationships between them. So logically speaking, when we think of a person, we can understand what kind of connections does this person have with a place. We can think of a person who's living in a place. We can think of a person who built the place, and so on and so forth. So once we understand that there is a type of the node of a person, and there is a different node that has the type of a place, we know that there is a list of relationships that can exist between these two nodes. And this list of relationships can be described in details and standardized. So anyone who's using this database and anyone who's using your data later on will be able to understand what exactly is the relationship between these two nodes. And ARCHES allows us to use ontologies. And the benefit of that is that once the data is within the system, once the data is modeled to the system, then any researcher later on will be able to use these relationships in a standardized way. They can just take a look at the ontology system and immediately understand that between any of the places that you can see in the database and any of the persons that you can see in the database, there can exist relationships of maybe 10 or 11 types that are standardized and recorded within the ontology. And queries can be run based on this standardized format. So this allows the database to be used all over, in all different types of researches, all over the internet. Everyone who has access to the database, so long as they understand how the system works, they can extend it, they can use it for their own research as well. And you can also add more data to the database. So if your data adheres to these principles, then it can be added to the database within ARCHES easily. Now, one final note on the data modeling within ARCHES is that you can start with the same system that we have done here. So you start from the data, build your way into the data modeling process, and then into the resource model. Or you can start from the resource model and then start collecting your data to adhere with the resource model. We are using a combination of both. So for the very early stages of development, we try to accommodate as much data as possible. But then later on, once the data starts to grow, you have to use a standardized system and collect the data based on it. because otherwise your database will be sparse and will not make a lot of sense in terms of research. So for using arches, at the moment, we have a combination of both the resource models that were built from the data, and we have resource models that were designed for specific purposes, such as activities and heritage, as Azada have shown already. There is a similar structure within arches that allows you to do standardization for the information that you yourself have added to the system, which I haven't talked about because Junaid will take the lead on that. And with this, I hand back to Azada for the Q&A.
Is there, Michael is asking, is there a standard set of ontologies?
Well, there are multiple standard sets of ontologies. The one that Arch is using is called CRM. We can provide a link to that in the chat in a bit. I'll find it and I'll send a link here. You can, yes, exactly. That's the name of the ontology. Thank you, Rebecca and Stefania. You can see the link there in the chat. And the reason why Arches is using that, because it's quite common to use CRUC within the archaeological circles. So there are multiple data sets that adhere to the same system. Of course, there are other ones, but most of them are specialized for their own purposes.
Thank you, Mahmoud. Yes, and we're going to have more specific sessions on both the modeling side and the ontologies and the SIDOC CRM with our partners to explain this part a bit more. And I believe that there are other ontologies that you have. You can import them also as well in Arches if there is a need. But the main thing that Arches uses is the SIDOC CRM. And as Mahmoud said, because it's very widely used. Okay, I can read out the question. Asim is asking, I would like to know whether this open source Arches is script-based or GUI-based database GIS system.
Okay, so Arches has a GUI. GUI here is graphical user interface. So what you usually see in Windows and within any web app that you're using, most famous is, for example, like Facebook, any social network. This is graphical user interfaces where there are menus and buttons that you can click on. So yes, Arches have that. You can use that. You can use Arches purely using the GUI and it will be absolutely fine. If you want to dive a little bit deeper within Arches, there are, of course, within Arches APIs and script-based interfaces that can be used. But of course, this will require specialized knowledge to know how to deal with them. So for the general public, we try to stick with the GUI because it's much more accessible and much easier to deal with.
Thank you. We have Kazala here next. Kazala, if you can unmute yourself. Thank you.
Okay, thank you very much for your presentation. I'm very much interested in the open source aspect of Arches, especially when as regards to satellite imagery. Maybe I didn't hear you very well, or maybe you didn't mention it. I would like to find out. One of the troubles I've had with satellite imagery is the aspect of resolution. So with Arches, is there any possible access to high resolution imagery, or like for example, with the problem I have of dealing with the resolution where you are not able to see certain archaeological sites for analysis. So maybe, I don't know whether if you can touch on that. Thank you.
Thanks, Kazala. I can start and then Mahmoud and Junaid can follow. interface, the user interface of ARCHES and the satellite imagery that you can add, these are mainly from the freely available ones and not the high resolutions that you might need to do your detailed analysis and kind of especially for remote identification of sites if you're using. So those are the things that you can do outside of ARCHES using other softwares and then import that information. There is a way that you can add, if you have other imageries, you can add them as layers, but it doesn't come with, and it's not free, and it doesn't come, if it's not free, then it's not free, and you can't add it freely to ARCHES. So I'm not sure, Mahmoud, Junaid, if there is anything more that needs to be added here.
No, not really. Yes, as you said, ARCHES relies on sources of imagery that you will provide. So ARCHES comes with integration to Mapbox, and you can add other surfaces if you like, but it will not provide you with access to data that otherwise is not accessible.
Thank you.
Sure. So Pamela has a question. Do you want to read out your question? Okay, so the question is the database able to deal with TIN digital vector format, which is used for storing elevation data?
So TIN is triangular irregular networks, which is a form of 3D modeling of surfaces. And if you want to embed 3D model within ARCHES, as you might have seen, the interface is already 2D. So it will not be able to visualize it in such a way as possible maybe with ArcScene, which is specialized for the 3D visualization. You wouldn't be able to see as much as you would see from such softwares within ARCHES. But information within them, being points and elevations, can be modeled to be inputted in the system. And we hopefully, if data is available for that, it can be used for queries later on. But if you look in, again, in terms of visualization, then no, ARCHES is not the best platform to use for this particular type of visualization. There are plugins and add-ons that can be added into the system to use it to visualize 3D modelings, like all sorts of 3D models. But again, I wouldn't say that this is the best use directly within the main interface of ARCHES. If such data is available, can be integrated. It's not supported in the 2D interface.
Thanks, Mahmoud. There is another question from Asim. Asim, would you like to read out your question? The question is the software API can handle total station data for creation, contour, or topographic map?
Okay, if you mean that ARCHES itself created a topographic map, then, well, it's not within ARCHES at the moment, such algorithm of collecting the points and then creating contours out of the point and then geographical map. This is not, again, the main purpose of using ARCHES. Such query can be designed and can be embedded within the system. I can see no theoretical reason why this is not possible, but it exists already in other softwares, and it's much easier to do it in other softwares. So I wouldn't say that this is the best use of ARCHES here. If you mean, can the data of contours or topographic maps be embedded within ARCHES, then being vector data, it can be uploaded to ARCHES. But again, it wouldn't be extremely useful for terms of, in terms of analysis or in terms of processing within ARCHES. I'm not quite sure what is the use case that you will require contours or topographic maps to be within arches and what kind of queries you will run on that, I can see a use case of adding topographic maps as rasters and being able to visualize it and being able to extract information from the contours as vectors as well. But this will depend on the type of the query that you will require. So again, Arch is quite malleable. We can design add-ons and custom algorithms for it, but all of that comes at a cost of development. So if another software already has these features, we would prefer to use it before trying to develop our own.
Thank you, Mahmoud. There were two questions that one Junaid answered. Do you want to, Junaid, explain? Because I think that might be a question from other people. That the question was mainly about how, in what format data can be uploaded into Arches, and that was, I think, mainly when I was talking about CSV and data upload. Junaid wrote the answer, but I think if you can maybe explain, since we have time, 5 minutes, that would be useful for others.
Yes, I can. Mahmoud, should I explain these? I mean, so there are basically two questions about. First question was how interoperable Arches is with other GIS platforms that archaeologists normally use, such as ArcGIS or QGIS. I mean, so from our discussion so far, we have sort of understood that each of the software has its own powers and functionalities that can be useful for developing data or managing data and performing different types of analysis. And as I mentioned, so Arches is basically an open source software. So since it has been released, the community, the development community is continuously working to increase the functionality and components that the Arches has to offer. And this interoperability need is also one of the requirements that is coming up by different user groups that are already using Arches. So in the latest release of Arches, now in the Arches 5.2 release, there is an initial version of interoperability that allows you to extract the data from Arches in form of a URL and then add to QGIS using the same URL. But as I mentioned earlier, there is certainly a lot of room for improving here in terms of authentication, security, and all of these features that we hope to see in a refined way as this development is progressing with Arches. I hope that answers your question. But if you need any other clarification, please do let us know. And
sorry, Junaid, just to quickly add. I mean, it goes back to what the needs of the users and of the people that are producing the data are. I mean, the reality is that we are constrained by the fact that as users, we use a lot of proprietary software still, and they have their own formats that are incompatible with other systems, whichever these systems are, whether they're still proprietary systems or open source systems. So I think in general, the preferred format for data interoperability is CSV or text, just because we know that once the data are in that format, then all of the software will have a function that is able to input or export this type of data. But again, if as a project, one decides that their preferred format for entering the data is a shapefile or something of this sort, this can be catered for and there can be adjustments that are made. It's just that I think globally, all the community that uses GIS and remote sensing prefer to use the simplest data formats, even because they are more sustainable in the long term. CSV will always exist, hopefully, but it's one of those formats that has been lasting for a very long time and will continue to last. So even if the software changes, you know that you can export your data and upload the same data set in a new software that uses maybe a different format. Whereas there are other proprietary formats that cease to exist. They become deprecated, and then you are left with a data set that you can no longer open. I'm sure it has happened to many of you. For your projects 10 years ago, you saved the data in certain formats, and now you can't open them with any software. And so I think that the choice of CSV is also to guaranteeing a long life of the data sets.
Yes. There has been another question by Rob Wiseman. I mean, it's sort of related to what Stefania has explained and the previous question. I mean, so ARCHIS has certain requirements and guidelines about the structuring of the data, some of which Mahmood has also shared in his presentation, that the data has to be modeled in a particular way. So if our data is available in another format initially, for example, in form of the shape files, I'm not very sure about the DWG files because this is a different format. However, in whatever format it's available initially, we need to assess that if this could be transformed into ARCHIS compatible structure that is mainly a structured CSV file at the moment. So during this project, as we progress along with both the projects, MAEASaM and MAHSA, there would be this data development and data import pipelines that would ensure that whatever mechanisms we are using to develop the data can be converted to the ARCHIS compatible format and imported to ARCHIS.
Thank you, Junaid. If there are no other questions, I don't see any new hands. And there was only one other question in the chat about whether information about intangible heritage can be added or handled in ARCHIS. And as I replied quickly there, ARCHIS is mainly developed to record data or information of tangible heritage, and specifically immovable, but it's also can be used and a bit customized for movable heritage. You can also add a resource model, a structure for adding information for your intangible heritage, but it's based on it should be based on what information you're collecting or you need to record. And one thing that might be something that is missing in what comes with ARCHIS is the ontologies, the CDOC CRM that ARCHIS uses might not have everything that you need to model your intangible data requirements.